So thank you, Christian, for the introduction. I'm Giovanni Rusconi, and I work at Ecofast. Today, I'm going to present you Eresys energy project, but before I would like to take say some minutes in order to introduce you Ecofast and what is our value proposition. I want to specify that we are not expert of biochar, but due to the support and collaboration of partner, we achieve interesting results that I'm happy to share today with the green carbon community. So Ecofast, born in Milano in 1998, thanks to Piero Rusconi, is my father. And the initial idea was to develop in Italy technology dedicated to the selective separate collection of food waste. So basically, it saw an incredible potential in the kitchen food waste disposers that are those tools that you can find in the kitchen under the sink, especially in America, which are very comfortable tools, able to intercept the organic waste at the source where it is generated. The enterprise has more than 20 years of experience in this sector, and since 2008 we start also to design and manufacture a new machine, especially for the professional kitchen sector. And among the years, we develop international partnership, but also distribution networks. Okay, but what do we do at Ecofast? So to start, like food waste management is known to be difficult, and is still very expensive if we consider that food waste accounts for 40% of the total waste generated. So it's sad to imagine the environmental and economical impact of, for example, transportation. Then, from our personal experience, even in the most advanced European countries, where the separate collection system is in force since 30 years, the improper materials, so plastic, metals, reach often between 15 to up to 20% of the total. The reasons are multiple, let's say. For example, people education or lack of comprehension. But for sure, there is a value chain gap due to the net separation of who is producing the waste and the final user or the transformer. So our machine process waste following two mechanical principles: grinding and the watering. So the grinding process can differ from the most common one that you can find in the market, because doesn't involve any rotating blade, but is performed through a centrifugal force. So imagine that the food waste that falls above a rotating plate, which push the material against a fixed ring that has abrasive function. And due to this mechanism, the process is considered in a way selective for materials that are inappropriate. So, for example, plastic, being lighter, will not be processed, rather accumulated in the center of the rotating plate. While in the presence of, for example, metals, the machine stops. So the second principle is dehydration, that usually occurs by pumping the ground material into a hydro extractor, which is the unit that physically perform the centrifugal dehydration process. So separating the liquid part from the solid through a cylinder, perforated cylinder. So this process of grinding and dewatering generate two fractions, a solid one and a liquid one, that they have unique characteristics. And from our perspective, this pretreatment helps all the other downstream process of waste valorization. Okay, so in these images, you can see Ecofast unit, the one that perform grinding and the watering process under the same cabinet. But we offer also to our customers the possibility to perform the grinding in the kitchen, for example, and through a pipes systems, the watering process is performed in another room. But in this case, the water input is important because water acts like a vector in order to bring the ground food waste from a place to another one. Okay, so after introducing you Ecofast equipments and their main characteristics, I can finally start to speak about Eresys and the idea of developing robust micro-decentralized circular economy. Because since I became operational in the company, let's say a new young team is trying to promote this concept of decentralization. And our idea is that due to the strategic placing of Ecofast technology, which are located at the source where the waste is generated, integrated valorization project of selected and therefore high quality organic waste can be triggered. At the moment, the main valorization lines that we are promoting are the composting of the solid fraction, but also the pyrogasification, which now I'm going to show you, that is performed through a small cogenerator. But this only after drying and pelletizing the ground food waste. Then we are also studying and promoting through a collaboration with the Spanish Research Institute, the bioelectrochemical filtration of the water coming out from the different process. And all these experiences have been tested and developed thanks to the support of this technological partner. So, okay, here you can start to understand better what we achieved so far in the Eresys energy project. So the system has been designed for customers that on average produce daily 500 kilos of food waste. This fraction through Ecofast grinding and the watering unit is processed into 250 kilos of the water material. Then, thanks to its own unique characteristic, this material can be dry out in an easy way, obtain on average 50 kilos of dry food waste. This 50 kilo of dry food waste, once pelletized, can be used as a feedstock, as a biofuel into the micro-pyrolytic cogenerator. In my opinion, this amazing system, this amazing system is based on biomass gasification and Stirling engine, which is particularly suitable for this application because it is insensitive to the kind of feedstock, and compared with traditional internal combustion engines, has also lower noise emission and lower vibration and higher efficiency. So Kira is the company that designed it, is located in the central Italy, and they construct a super automatic system regarding, for example, biomass loading or biochar discharge. And they are able to reach very high temperature of gasification. And if we consider like a consumption of 2 kilos of pellets per hour, the output after a working day of this process are, so as you can see, 6 kilos of biochar, 1 kilowatt hour of electrical energy, and 5 to 6 kilowatt hours of thermal energy. For us, it means 500 liters of water at 65 degrees. And later you will understand why I'm saying this. So during our experience, we produce pellets of 2 different types. One was a mixture of food waste, and one was coming from a monomaterial that was platano peels. The dry process was performed using a standard commercial electric dryer that, due to its small dimension, was a bit a bottleneck for the experiment. In fact, the pellet that you can see here was composed by 50% of dry food waste and 50% of sawdust. This was in order to reach the right amount of pellets in a short amount of time and perform tests with the cogenerator enough long to achieve like interesting and trustable results that now I'm going to show you. Yes, before I want to show you that the company Kira implement AI automation and an incredible remote control that allow them to have a prediction in diagnosis and therefore reduce the maintenance. So in these tables, in this table, you can see the performance that we achieve, and they are compared with the performance achieved with the system using standard wood pellets that are figured in the green table. So as you can see, in both cases, with the organic waste pellets and the platano, the efficiency in the energy production are similar to the standard pellets. The main difference was regarding the emission levels, because we register high level of CO and NOx compared to the wood pellets. And even if they told us that that the levels are very low, I have to say that at the beginning this aspect worried me a bit. But consider that in their machine, their unit, they neither consider a scrubber due to the very low emission. I thought that, okay, we can study the way to control better this aspect. Okay. So in the last two slides, I want to speak about our future perspective. At the moment, one of the most interesting market that we are facing is Maldives, and the resorts that are located in these different atolls. So before 2021, the resorts which were producing mountain of food waste daily were allowed to discharge the organic material directly into the ocean. And but it seems that due to a new legislation, this practice, fortunately, is not anymore allowed, and therefore they are everybody is desperate to find solution. So our idea is to design what we call eco gazebo with the Eresys energy solution that we consider the best option for Maldivian, because compared, for example, to composting, due to the lack of space, can be a problem. So then if we consider also the energy, that the energy is such an important resource there, because they burn oil for generated. We are designing a dryer that is fully connected to the cogenerator in order to perform the process of drying the food waste using the thermal energy that the system produces. And from our first results and calculation, we think that we are able to reach autonomy in the process from the energy perspective point of view. But we are still working on it. So, in order to conclude and consider that fresh water is such an important resource, especially in Maldives, I would like to give you some insights about a project in which I believe a lot. This project was supported especially by Indeagua, that is a research institute in Spain, and Medfilter, that is the spin-off of the institute that is designing and commercialize bioelectrochemical filtration system. So in our case, the organic rich water coming out from the Ecofast, the watering process, is pumped into a septic tank that act like a reservoir. Then the natural-based solution that is known as Metland act as a natural biofilter. And here the organic soluble fraction present into the liquid is biologically oxidized by an electroactive microorganism population, which is able to interact with their metabolism with the conductive material, for example, biochar. But apart from the filtration purpose, the idea is also to recover the inorganic fraction under the form of a new nutrient solution, which can be exploitable for the growth of photosynthetic organisms, for example, in the hydroponic or vertical system. Or also, I don't know, through fertigation for gardens and nothing. I like a lot this kind of solution. For me they add aesthetic and regenerative value to the landscape, and at the same time they provide also ecosystem services. So finally, here you can see some results of the organic removal performed due to the oxidation of the organic matter present into the liquid that I call Ecofast juice. So as you can see, in 24 hours, we were able to pass from level of 2,000, but even higher, 25,000 milligrams CD per liter, arriving to 1,000, even less, 200 milligrams CD per liter. Here you can see the team, part of the team of Ecofast. And I finish. I would like to thank you, everybody, and I'm available for any question.
Thank you very much, Giovanni, for this presentation. That was very interesting. Also nice to see the difference from an industrial system to a smaller scale.
Yeah.
So my first question would be, okay, because for gasification, for pyrogasification, often you have issues with pH contamination of your char. Did you check for that already?
No, I have to admit, no. We received from the enterprise the characterization of that they have for the standard wood pellets, but we didn't have time to test on our feedstock, let's say.
Okay, yeah,
Unfortunately.
I think that will be quite interesting to see, because some gasifiers are quite good for biochar production, but others are rather nasty.
Yeah.
At least, but I like the circular idea of your system.
We had some problem, some blockage during the experience, but then we understood that was they were related to the size of the pellets, because we pelletized the pellets too long, and they were like having some block inside the reactor. So then, after understanding this, we changed, and we understood that was the main problem in the blockage that we register.
So have you did you think about the cum removal capacity of your system? Did you do any life cycle analysis so far?
No, I have to admit not, but as you can see, for example, if we start from a feedstock that is 500 kilos of food waste, through the grinding and the watering process and the dry process, and then we arrive to a percentage of biochar that is not very big. I mean, we pass from 500 kilos of food waste to 6 kilos of so the percentage is around 11-12% of. But regarding the removal of CO2, like to give this perspective, no, we are still we have to do the analysis. Now we were more focused on the mechanical process, on perform the experiment rather than understand this aspect.
Yeah, I mean that makes sense to start
But
there.
yeah, of course, make sense to proceed in that direction for sure.
So you got a question from Sabila. He or she was asking, hi Giovanni, very cool presentation. Does the machine emit a garbage smell? So do you have any issues with smell?
During the drying process of food waste, you can have some smell. But once the material is dry out, I felt that there was a difference in the smell between the machine working with the wood pellets compared with our pellets, but was not a garbage smell. Let's say was not stinking.
Okay.
Was slightly different. That's it.
And the next question from Sabila was, is the 500 kilograms of food waste the daily capacity? And how long does the process take from food waste to biochar?
Okay, so the 500 kilos is the daily so that the cogenerator is working with 2 kilos per hour among the 24 hours. So that's why we had to produce that amount to let the machine work for an entire working day. But being very small is also are modules that can be repeated. So if you start with a model that if you need a higher capacity, you can repeat the same module. So being modular, let's say, you can repeat the same sketch. But the machine itself, yeah, has that capacity, of course. Then regarding the 500 kilos of food waste, of course, depend of which kind of food waste, because, for example, not all the food waste has a reduction of 50%, for example, in average, or 80% in volume, as I show in the slides. That numbers are considered an heterogeneous food waste. Then working with monomaterial, for example, you can set more the quantity, you know better the quantity of dry food waste and the hydrated food waste.
And how long does your process take? So if you start with your food, so you get your food waste, how long does it take to become biochar in your process?
So if we consider that the grinding and the watering process is super fast, 500 kilos, depend on the capacity of the machine of Ecofast units, you can perform it in less than 1 hour. Then you have the drying process. The drying process is taking from our first test between 20 to 24 hours. As I said, we perform this using a standard dryer, electric dryer. And then once you have the pellets, that the pelletization process is quite fast. You load the machine, the cogenerator, and that the 2 hours kilos of pellets is the range. I mean, the machine is using 2 kilos of pellets per hour. So that is a bit of scale. Of course, in the end, what we are thinking is a module, let's say a container that is doing everything automatically. Now we are in the phase that we are testing the machine one after the other one. The idea is to have a container where you put food waste one side and you have biochar on the other side, and electricity and thermal energy. That is the objective.
And the next question from Marshall was, are your intentions to sell this technology? And if yes, what's the price?
Good question. So,
I mean, a range is
the
also,
full pack.
I guess.
The full pack. Yeah. Let's say the range is between of the full, let's say the container version. What I was because the idea is to deliver to the customer an automatic version is in the range between 100 to 150,000.
So Marshall, if you want to buy some, that's your call now.
That would be great.
So I give you 1 more minute to ask any follow-up question if you have some. So Marshall says, call me. So that's your first customer. Thank you very much, Giovanni, for your presentation. So I